another day's lecture on ergonomic considerations that we use in design of machine elements. So continuing where we left yesterday, see the displays, if they are having a pointer, they should have knife edge with a mirror to minimize the parallax error. You know parallax error. So if you are not exactly from above the point you are not seeing, then you may end up with some parallax error. So therefore a mirror should be there beneath it, so that the image in the mirror and the pointer, if they both are matching, then you will avoid parallax error. And it should have a knife edge, it should not be blunt edge. Okay, as we have seen, see these are the knife edges. So this knife edge is more pointed. Okay, so it should have knife edge. And then next, the numbering should increase in clockwise direction on a circular scale upwards, circular scale, and upwards on vertical scale. You see, here we have seen, you see, on a vertical scale, numbers are increasing from down to as you go up. And here also, in the circular scale, how the numbers are. You see, you won't put 0 here and then you come like this in the counterclockwise direction. In the clockwise direction, you put the readings, the numbers. Okay. So the numbering should increase in clockwise direction on a circular scale, upwards on vertical scale, and rightwards on a horizontal scale. If it is in a horizontal scale, this is a horizontal scale, it should increase rightwards. That means 0 should be on this side, and as you go to the right, the numbers should increase. Okay, so that is how in 3 types you should be numbering them. Then differentiation in display group should be made with the help of color, shape, and size. You see, there are different groups and you want to differentiate them. That means you want to clearly identify them. Then you should use different colors for different things, different shapes, and different sizes. You see, what for? Everything for the convenience of the operator or the human being who is present there. For man, it should be easy. Okay. Then important displays like warnings can be made more effective by the use of flashing lights. If there are any warning signs, then flashing lights, if you use, then it will be more effective. See, here you can see some dials, how they are numbered. You see here 0, 1, 2, like this in the clockwise direction they have gone. Here is an example of digital display. Say the meter reading here is given in the form of digits. Here is a display how our fuel meters are shown in a car. Here empty, and this is halfway through and it is full, tank full. Okay, this is how the fuel meter in some of the cars is shown. You see, for warning, 1 minute. See, for warning, here, if you are not wearing seat belt, you will see this, this symbol flashing. So a warning belt, can flash on off. It will go. So it is warning. Here is an example of horizontal linear scale. Some gauge control display. It is, you see, it is goes from left to right, increasing. Here is an indicator of a vertical scale. How the LPG level indicator, it shows empty to full like this, slowly increasing. So these are some of the examples of this. Okay, now let us come to working environment and safety. You see, where man is working, the environment affects his working. You see, and there are various functions which are performed by man in the industry, like he may be supervising, he may be controlling, he may be doing the maintenance work, uh, and he may be repairing the equipment and other things, or he may be working on the equipment. The environment affects the efficiency and the health of the operator. So the most important factors which affect the efficiency are listed here in this figure. You see, one is lighting, then noise, temperature, and humidity. Humidity and air motion. These are the factors affecting. Okay, let us see one by one how lighting affects. So the intensity of light in the surrounding area should be less than at the task area. This task area means exactly where you are working. That should be brightly lit, and the surroundings need not be so brightly lit. It should be the intensity on the surrounding should be less. This makes the task area focus of attention. Okay, so operator will become less tired if the lighting and color schemes are arranged so that there is gradual change in brightness and color from task area to the surroundings. It should not be that see the area he's working is bright and all the surroundings are dark. It should be gradually the change should be there. See, it's not that the surroundings should be fully black, fully dark. So the gradual change should be there. Then he becomes less tired. You see, this fatigue, that human fatigue comes when he gets tired. Okay, so he'll be less tired when the lighting arrangement is such. The task area should be located such that the operator can occasionally relax by looking away from the task area toward the distant object or surface. So it should be located in such a way that occasionally relaxation also he should be able to see. So especially some people, like assembling watches and all, they will be intensely working on the minute parts. See, those people, occasionally be permitted to relax themselves by looking at away. Then glare often causes discomfort. Glare means bright light coming into their faces. It causes discomfort and reduces visibility, and hence it should be minimized and if possible eliminated by careful design of lighting sources and their positions. So this is about the lighting. Now let's come to noise. Noise also, you see, about lighting, one more thing I wanted to say. You see, now most of the factories, you see, where they are working, you see, the factories, how the roof will be. Normally roof will be made of sheets. पतरे का बना रहता है और पतरे के बीच में तुम देख सकते हो वहाँ ट्रांसपेरेंट पतरे भी रहते हैं ताकि सनलाइट, नेचुरल सनलाइट मशीनों के ऊपर आ जाए और वहां पर लाइटिंग की कोई जरूरत नहीं पड़े. ओके, सो दे यूज ट्रांसपेरेंट sheets and where necessary they will use the electric lights also. Okay, coming to the noise. Noise also, you see, there is a limit for human ear, how much you can hear. You see, human is a limited being. He cannot see very less sounds. He cannot hear decibels of maybe some 10 decibels and below that, or 20 decibels and below that he cannot hear. and very high decibels also he cannot hear. He can hear only within a range. That's why, some of the noises which dogs can hear, man cannot hear, because it is not within our range. See, the things that we see, there is a limit. The spectrum that we see, only the visible light, that only we can see. See, ultraviolet rays our eyes cannot see. Infrared rays of the spectrum our eyes cannot see. We can see in a limited range. Similarly, we can hear also in limited range. Decibels is the unit of sound. Okay, so many decibels only we can hear. So the noise at workplace causes annoyance. If there is a constant noise of high decibels, it annoys him, and damage to the hearing. You see, suppose if constantly there is high noise of the pneumatic air or something, see, sometimes it will be damaging to the hearing, and it reduces the efficiency of that person when he is working. So ये जो ज़्यादा आवाज़ जो आता है, अगर लगातार आवाज़ आता है तो उससे वो परेशान हो जाता है, और उसका सुनने का कैपेसिटी जो है वो अफेक्ट हो जाता है, और उसका उसका जो काम करने का जो एफिशिएंसी है वो भी कम हो जाता है. The industrial safety rules specify the acceptable noise levels for different workplaces. You see, the rules and the regulations which are framed by the government for the industries, they specify what are the acceptable decibel levels. Within that only decibel levels should be used. Suppose constant noise is there, then they will use earplugs and other things. But constant noise, if it is coming, then sometimes they will lose their hearing. It is a hazard for the ears. Okay, coming to next to the temperature. How the temperature should be. Okay, an operator to perform the task efficiently, he should neither feel hot nor cold. It should not be extremely cold. Anyway, in our country, we don't have so much cold, but in some other countries, where the ice is there all around, and they may feel very cold. And for us, what we usually feel is, we feel it is very hot. Okay, when the heavy work is done, the temperature should be relatively lower, and when the light work is done, the temperature should be relatively higher. So that is the reason when centralized air conditioning is used. You see, people who are sitting in air conditioners can think properly, can interact properly, can do their work more efficiently. That's why those people who have understood this thing, what they do is, they, even though it is costly to provide centralized air conditioning for the entire thing, see, they understand that it is in the long run more beneficial and more profitable to provide AC rather than allowing the workers to work without AC. Okay, anyway, whatever money they are spending, it will be paid for by the increased efficiency of the worker, and by the more output that they are giving. Okay, then humidity and air conditioning. See, temperature we are controlling by air condition is one thing. Coolers also you can keep like that, or you can you cross ventilation and other things you can provide like that. Okay, then humidity means how much, we measure humidity by the relative humidity. That means in the air how much water vapor is there. Okay, how much water vapor is there. And so that is the humidity. Humidity has little effect on the efficiency of the operator at ordinary temperatures. At the room temperatures, maybe around 27 degrees centigrade, it has not much effect, but at high temperature, it affects significantly the efficiency of the operator. You see, sometimes humidity is such that some person will be pouring sweat, it will be coming like that. In such an environment, no, you see the efficiency of the operator is drastically affected. Okay, the proper air circulation is necessary to minimize the effect of temperature and humidity. So all these things should be you see here is an example when you because of ergonomics in workplace, in industry, if you want to lift a load, how you should lift. This is not the right ways where the spinal cord is bending like this. See, you should bend your knees and lift it in such a way that this spinal cord is straight. And here you see this how this lady is bending when she is working on her laptop, and how it should be straight. And when you are working in front of the computers, how it should be. And when you are working with the computer, where your eyes should be, at what height your eyes should be, you see. And your elbows should be at 90-degree here, and the hip and the legs, no, the angle should be 90 degrees. This will be the office ergonomics. uh, the top monitor level should be in line with the eyes. And when you are uh, pushing some load about a steep slope, how your posture should be, so that you will not hurt your back. So when you are seeing the mobile phone also, see how this spinal cord should be straight, not bent like this. And when you are answering on the phone, see, your spinal cord should be straight like this. For that you can use headset. You should not be putting the phone between your shoulder and head, and not twisting the thing like this. Okay, these are not desirable things. Let us come to another topic called preferred numbers. In industrial design, in machine design, preferred numbers are the standard guidelines for choosing the exact product dimensions within a given constraint. That means, you see, suppose, you see, here is an example. You see, in the design, it is told to us that you have two screws in our machine that should be placed anywhere between 12 mm to 55 mm apart. So where to exactly place it? This is the constraint. In this constraint, 32 to 55 you have to place. So there we choose it 40 mm. Why? Because see, 4 is in the R5 series of preferred numbers. You see, this is the R5 series here shown. So here 1, 1.6, 2.5, 4 and 6.3. So here 4 occurs, whereas between 32 to 55 nothing else occurs. So 4 means, the 40 it is chosen. See what is R5? I will let you know in a minute. Okay. See, the product developers, they have to choose various lengths, numerous types of lengths, numerous distances, numerous diameters, numerous volumes, and numerous other characteristics, other quantities you have to select. So for selecting this, a series of preferred numbers are designated. These preferred numbers, they are designated as R5, R10, R20, R40, like this. Okay. So these preferred numbers are important tool which will minimize unnecessary variations in sizes. As I was telling you last time, in standardization, one of the method is we need not be having so many numbers, so it will be tedious for the stockist and for the manufacturer also to make all those things. So here also, see, through these preferred numbers we are minimizing the variations, unnecessary variations we are minimizing. A complete range is covered by minimum number of sizes. Only a few numbers of sizes are specified, and this is advantageous to both the producer also and the consumer also, or the customer also. See, with the acceptance of standardization, there is need to keep the standard sizes or dimensions of components in discrete steps, or in few steps we want to keep. The sizes should be spread over wide range. At the same time, they should be spaced properly. So the diameters of the standard sizes are between 10 to 25 mm. They should be 10 mm, then 12.5 mm, 16 mm, 20 mm, 25 mm, like this. See, this leads to use the geometrical series known as preferred numbers. See, preferred numbers series, yeah, in the previous thing that I have shown, it was shown as R5. Here it is shown as S5. I think more commonly they use R5, R10, like this only. This is the series. See, in the series, how do you get these numbers? See, the multiplying factor is the fifth root of 10. Fifth root of 10 is 1.58. With this 1.58, you have to keep on multiplying the things. Then you will get that series. Okay. Fifth root of 10 is 1.58. So that is why fifth root, therefore it is R5 series. If it is 10th root, then this is R10 series. 10th root is 1.26. 20th root is 1.112. This is R20 series. 40th root is 1.06, that is R40 series, and 80th root is 1.03, that is R10 series. See, and what are they saying? For establishing a series, first a number is taken. multiplying this number by a series factor, the second number is obtained. That means first if it is 1, then multiply by 1.58. So 1.58 will be the second number. Now multiplying the second number by a series factor, this is the series factor, no, 1.58 for R5 series. So first is 1, second is 1.58. Now multiply the second number, that is 1.58, with the series factor, that is 1.58. Then you will get the third one. Okay. Now the third number is obtained, so on. Like that the series is obtained. Yeah. Let us see here. These preferred numbers, there are 5 basic series with step ratios. And this is 5th root of 10, 10th root of 10, 20th root of 10, 40th root of 10, and 80th root of 10. These ratios are approximately, you see, the series numbers that we have seen. The 5th root of 10 is 1.58, 10th root of 10 is 1.26, 20th root of 10 is 1.12, and 40th root is 1.06, and 80th root is 1.03. So these 5 basic series of preferred numbers, they are known as preferred series, are designated as R5, R10, R20, R40, and R80. Okay, suppose you want to select standard shaft diameters or power rating of couplings, center distances of standard gears, etc. These preferred number series are used. Okay. Okay, here an example is given. According to R10 series, if a manufacturer wants to introduce the models between 15 to 100 units, then his series will be, see what comes, and that man is following R10 series, so it should lie between 15 to 100. So he will choose like this: 16, 20, 25, 31.5, 40, 50, 63, 80, and 100. You see, from where are you getting this? You are getting from this R10 series. See, all these things will be available in the tables, in the data books. Now, what are the advantages of preferred numbers? The difference in two successive terms has a fixed percentage. This is first point. Second is, it provides small steps for small quantities and large steps for large quantities. You see, if you have to choose between 5 and 10, small steps. If it is between 5 and 100, large steps, like that. The product range is covered with minimum number of sizes without restricting the choice of the customers. You see, the product range, see, suppose somebody wants something around 50 mm. If 50 is not available, is something lesser than 50 or more than 50 is available, he will be able to choose, not with much variation. So there we are not restricting the choice of the customer, but almost what size he wants, approximately to that size we will be getting. But thereby what we are doing is we are minimizing, it is beneficial both for the producer also and for the consumer also. You see, according to the standardization, the variation should not be much, it should be limited. Okay, there is a need to keep the standard sizes and dimensions of any component or a product in discrete steps. So this is about the preferred numbers. This is dealt as a theory topic, only for theory it will be asked, and only that you should know how those series numbers you have got it. Okay, today we'll stop here. Thank you.